Hello, my name is Darrien, and today I will prove to you whether or not this function is differentiable at x equals 1. And if it is, I will state what f prime of 1, f prime of x at x equals 1 equals. I will do this by using the definition of the derivative at a point. This is also known as the limit of the difference quotient process. Let us begin. As you can see, f of x is equal to 3x squared when x is less than or equal to 1. That would be on the left side of this graph, the left side of this function. From the right side, f of x equals 2x cubed plus 1. Now, in order for this function to be differentiable at x equals 1, the derivative of these two numbers will have to be the same at x equals 1. Okay. Now, to start with, we will find the derivative of 3x squared through the limit of the difference quotient process, which is the limit as x approaches h of f of x plus h minus f of x all divided by h. That will give you the derivative. Now, when you plug this in, you get the limit as h approaches 0 of 3 times x plus h squared minus 3x squared all divided by h. Now, if we leave it like this, there isn't much we can do with this because you're dividing by h, and that's undefined, and that does not help us. So, hopefully we'll be able to cancel something out by multiplying out x plus h squared. When we do that, we get 3 times x squared plus 2xh plus h squared minus 3x squared all divided by h. Now, by using the distributive property, the associative property, and the commutative property, we can simplify this even further to get 3x squared plus negative 3x squared plus 6xh plus 3h squared. Now, simply by canceling out different numbers, we can get the limit as h approaches 0 of 6xh plus 6x squared all divided by h. This is much easier to work with because now everything is multiplied by a factor of at least h, which means that we can cancel things out. And when you do that, you end up with the limit as h approaches 0 of 6x, plus h. Now, in this case, you can replace h with 0 because it's approaching 0, and you end up with the derivative of f of x equals 6x. Now keep in mind that this is only from the left side, which would be from negative infinity to 1. Now we will find the derivative of f of x as it approaches 1 from the right side. Once again, we will use the same process, which is as the limit as h approaches 0 of f of x plus h minus f of x all divided by h. The limit as h approaches 0, when you plug these in, becomes when you plug in these values, the limit as h approaches 0 of 2x plus h cubed plus 1 minus 2x cubed plus 1 all divided by h. Once again, there is not much we can do with this because, simply put, there's nothing to cancel, and we need to be able to cancel out that h on the bottom if we want to work with this. So we multiply out x plus h cubed. We do it in two different steps. First off, we multiply x plus h times x plus h, which gives you x squared plus 2xh plus h squared. Now we still have to multiply this by one more x plus h, and when you do that, it gives you 2x cubed plus 2x squared times h plus h squared times h plus h times x squared plus 2x times h squared plus h cubed, all minus 2x cubed. Now, in here, I didn't just multiply those values out. You may have noticed that the plus 1 and minus 1 disappeared. That's because I canceled them. Now, by rearranging, now we'll distribute the 2 to all of this. So that we have 2x cubed plus 4x squared times h plus 2h squared times x plus 2hx squared plus 4x h squared plus h cubed minus 2x cubed, all divided by h. This seems extremely difficult to manage, but it's not, because luckily for us, a lot of these terms are the same term with different coefficients. Now when we combine like terms, all that we have to work with is the limit as h approaches 0 of 6x squared times h plus 6h squared times x plus h cubed, all divided by h. Now we can cancel same as we did in the last version of this, and we are no longer dividing by 0 now, which means that we can find this limit as h approaches 0. Because whereas before we were dividing by 0, which is not possible, now that is no longer a problem. And we have 6x squared plus 6x times h plus h squared. And as h approaches 0, in this case we can simply plug in 0 for h in the problem, which leaves us with just 6x squared. This means that the derivative of f of x from the right side, from its right side, is 6x squared. That's with the domain of 1 to infinity. Now we've shown that the derivative of f of x equals 6x on the left side, and that the derivative of f of x equals 6x squared from the right side. Now the only thing to do is find out what each of these values is at x equals 1, and if they are equal to each other, then that means that this function is differentiable at x equals 1. If they are not equal to each other, that means that this function is not differentiable at x equals 1. Let us begin. Now, the limit as x approaches 1 of f of x from the right side is 6x squared. That is equal to 6. The limit as x approaches 1 from the left side of f of x equals 6x. That, when you work it out, is simply 6. Because these two values are the same, that means that this function is differentiable at x equals 1. And the derivative of f of x at x equals 1 is 6. That's all that there is to this problem. I hope that you understand how to do it. I hope that this video has helped you. Goodbye.